Hi, it's Mrs. Allison. Hopefully you watched the Vertex form. That one has more information about the parent function. We're going to use that information to graph standard form. So if you have not already, I would go back and review the Vertex form video just so you get an understanding of the parent function, because we're going to use that for standard form. So today we're going to look at the standard form, and the standard form of a quadratic equation is the equation y equals ax squared plus bx plus c. This plus looks a little funny. Ax squared plus bx plus c. That's my standard form. Now, when I go to graph in standard form, there's a few things I'm going to do different than I did with vertex form. With vertex form, I found the vertex first. With standard form, I'm actually going to find my axis of symmetry. And so as we saw from the video before, that axis of symmetry is that mirror, that line that we can mirror image our parabola. So my axis of symmetry is the equation x equals negative b over 2 times a. That's my axis of symmetry. So let's look at an example that we can graph standard form. And I'm going to actually put in a pretty simple example to begin with, and then we'll move to a more complicated example. So let's graph the equation y equals, let's do x squared plus 2x plus 3. X squared plus 2x plus 3. So the first thing I want to do with standard form is I want to find my axis of symmetry. And the axis of symmetry is an equation. It's a vertical line that is my mirror. So I'm going to do the opposite of b over 2a. Hopefully, we know that b is the value that's attached to the x, and the a is the value that's attached to the x squared. So in this particular problem, negative b, or the opposite of b, would be opposite of 2, negative 2, over 2 times my a value, which is 1. So my axis of symmetry for this parabola is x equals negative 1. So I'm a visual person. I kind of like to get an idea of what I'm looking at. So I know my axis of symmetry is this line right here. There's my mirror. That's what I'm going to be creating my parabola around. The next thing I need to find is my vertex. Well, we know the vertex lies on the axis of symmetry. So to find the y value of the vertex, I'm going to plug my axis of symmetry back in. Y equals negative 1 squared plus 2 times negative 1 plus 3. Please watch your order of operations. We need to make sure we square this whole x term. So negative 1 squared is 1. Positive 2 times negative 1 is negative 2 plus 3. So we get negative 1 plus 3 gives me an axis of symmetry of 2. So a y value of my vertex of 2, which means that my vertex is the ordered pair negative 1, 2. So I'm going to graph that on my graph. And negative 1, positive 2 is right here. So there's my vertex. Now I need to base everything off of my parent function. Remember, the parent function, I'm going to graph it real quick with dotted lines hopefully, starts at 0, 0, goes up 1 over 1 in each direction, and then up 4, 2, 3, 4 over 2 in each direction. Oops. And so my parent function is this line that looks like that. I'm not sure how that got to be so straight. Okay, there's my parent function. So what I'm going to do now is I'm going to take my graph, and since my a value in this problem is 1, it means I'm using my parent function just as it is. I'm not changing any of the y values. So when I want to go graph my function, I'm going to start at negative 1, 2, but then I'm going to go up 1 over 1. And then from the vertex, I'm going to go up 1, 2, 3, 4 over 1, 2 in each direction. Oops. If only I had a fancy iPad Pro with a pen. Probably make it a little bit prettier. And there's my parabola. It fits. The parent function has literally just been moved left 1, up 2. Now here's the beauty of this. If I know my vertex, I could change this equation, the one that's in standard form. So this equation right here, y equals x squared plus 2x plus 3, I could change it to vertex form very easily. Watch. If I know my vertex is negative 1, 2, which it says it is right here, that's what we found, and I wanted to write it in vertex form, all I would need to do is make the substitution into y equals a times x minus h squared plus k. Watch how that looks. Y equals my a value. What did we say our a value was? It's 1. So 1, oops, let's put on a pen. 1 x minus h. Well, my h is negative 1, so minus a negative 1 would be plus 1 squared, and my y value is 2. So do you see these two equations? This equation right here, y equals 1, x plus 1 quantity squared plus 2, and y equals x squared plus 2x plus 3, they're the exact same equation. One's in standard form, one's in vertex form. Okay, let's change it up a little bit. Let's make it a little more complicated. What happens, or fun as I call it, what happens if I change that a value? How does that affect my graph? So let's look at this one. Y equals negative x squared plus 2x plus 5. I notice this is in standard form, so the first thing that I'm going to do is I am going to find my axis of symmetry. So my axis of symmetry is the equation x equals the opposite of b over 2a. My b is positive already, so the opposite of positive 2 is negative 2, times 2 times the a value. My a value in this case is negative 1. So I have negative 2 over negative 2, which is positive 1. So my axis of symmetry is positive 1. Oops. Now, what I'm going to do is I'm going to find my vertex. I'm going to find my vertex by plugging my axis of symmetry back in. So the y value is going to be y equals negative x squared plus 2x plus 5. And remember how I said you need to watch your order of operations? This is a perfect example. See how this negative sign right here is outside of what x is. It's not touching, it's not being affected by the squared. Only the x is squared. So what I'm going to do is I'm going to square the 1 and then apply the negative. So this would be y equals negative 1, because 1 squared is 1, apply the negative, plus, oops, this should have been, nope, I can't go back and erase that, apparently. This should have been times 2 times 1, let's just change that, plus 2 plus 5. So negative 1 plus 2 plus 5 gives me a y value of 6. So I know my vertex is the ordered pair, positive 1, 6. Okay, so I am going to graph that on my graph. Okay, here is my vertex is the ordered pair 1, 6. Oops, went a little high. My axis of symmetry is positive 1, so everything is going to be mirror imaged around that line. So I know my parent function tells me I should go up 1 over 1 and then up 4 over 1 if I didn't have an a value, but I do have an a value. What is my a value in this particular problem? My a value is negative 1. So what does that do? Well, it takes all the up part of my parent function, the up 1, always over 1, up 4, always over 2, and it's going to multiply them by that negative 1. So instead of going up 1 over 1, I'm going to go down 1 over 1 in each direction. That's my negative a value. Then I'm going to go, instead of going up 4 over 2, I'm going to go down 4, 1, 2, 3, 4, over 2 in each direction. And then I can sketch my parabola that shows it is upside down. Now, in all of these videos so far, I have not really talked about domain and range, but this is important too, especially on this particular type of parabola. This is the one where I've seen the most mistakes. What is my domain? Well, it's a parabola, so we know the domain is all real numbers, or negative infinity to infinity. I can include any possible x value, it works. This one, however, has a unique range because it's upside down. Remember, when we state range, we start from the lowest y value and go to the highest y value. In this case, my range is starting at the lowest y value possible, which is negative infinity. And the highest y value that I have is 6, and I can include 6, so I'm going to put a bracket. So if you have any further questions, please either just review these videos again or come in and get help. I'm available before school most mornings at around 7 or a few minutes after. And then during SOAR for sure, and make an appointment after school. We can work out times. Thanks, guys. Have a good day.